Hello and welcome to day 5 of 100 days of talking, I guess. Today is February 16th. Today we're going to talk about the 100 days format, and then we're going to talk a little bit about Python scripts, and I'm going to use an analogy to discuss those, and then we're going to talk a little bit about trial and error assistant. So just briefly, I want to touch on the idea that 100 days is more of a blog series and it's more of a conversation. And I want this to be a free exchange of information. So if you have any thoughts on anything that I say, if you have any other sort of questions that come up or anything you'd like to add or feel like you might want to share with me, feel free to leave it down in the comments. I'd love to hear from you guys. That being said, I don't really treat 100 days of coding as a good reference material. If you're looking to learn Python or learn more about these projects, I'd recommend you check out some of the other videos. But in this series, we're just going to do a brief overview, kind of touch upon some interesting things to think about while talking about Python and trial and error assistant. And don't worry, you don't need any Python knowledge to watch this series. It's all about just anybody can pick it up and have a conversation about these things. So if you're new to Python or you don't know what it is, you can come on along and I'll walk you through all the stuff. And with that being said, let's move on to our first main topic, which is talking about Python scripts as recipes. Now, imagine that you are a professional baker and you can bake a really good souffle. And you want to make souffles for everybody in the world because you think everybody's going to love your souffles, and they will. I'm sure they will. You make a wonderful souffle. But you don't have enough time. It takes far too long to make a souffle for everybody in the world. I mean, just making one souffle is a bunch of work, and even though it's easier for you, there's 7 billion people or something along those lines out there wanting to try your delicious souffle. So what do? Well, you could take your neighbor, invite him over, teach him how to make a souffle, and let's say, teach this man all the techniques that you know. It might take you a while to teach him, but eventually you could teach this guy how to make a pretty decent souffle, and you both could make twice as many souffles as you want, but still, that's not enough to feed the whole country, or even the whole world. And so you keep finding new people that want to make souffles, you hire new chefs, and you get them to come join you, and you make all your delicious souffles, and that's all nice and wonderful, but still, you're not able to make enough souffles to feed the whole world. So you say to yourself, well, okay, I'm just gonna, build a factory, I'm gonna have a factory that makes a souffle, and I'm just gonna have build a big machine that can do everything that I can do. And we know in the real world that these machines are not perfect. It's not gonna make a perfect souffle just like you can, but you can teach it to make a good enough souffle and sell it across the world. And a lot of people are doing that, and that's how you get prepackaged food. And it's not a bad idea, but it's tough because the physical world, it's hard to interact with and make a souffle because there's a lot of physical properties of souffles and whipping the egg whites and stuff that needs to be handled. It's hard to really mass produce. But in theory, you can make enough souffles to feed the world if you can just build enough machines to make those souffles. And here, just like in the example of a machine that makes souffles, we can write Python scripts to perform tasks on computers that we can already do ourselves, but do them more efficiently and maybe share those benefits with others. So in this example, if I wrote a script that would resize an image, make a 50% size image, a 75% size image, and a 100% size image, I want 3 pictures from my first one, I could just go into Photoshop or something and open it up and resize it and then save it, and it might take me 30 seconds to a minute. Let's say 15 seconds if I'm really going fast, but I've got 1,000 pictures, and so I've got to do this 1,000 times. 15 times 1,000 is 15,000 seconds. 15,000 seconds is about 250 minutes, which is a little over 4 hours. I'd have to spend 4 hours trying to resize these 1,000 images. But if I can write a Python script to do it, and maybe I can get it to do more than one image at a time using advanced concepts like multi-threading, then I can speed up that process and make it go way faster. And in practice, you're probably going to be able to do this task in just a matter of seconds. And so taking this 1,000 images and a task that would take you 4 hours would now take a couple seconds with a Python script, and you can have this running on multiple machines to do it in parallel. And so you've got 10 computers all processing 100 images. That'll go 10 times as fast as one computer processing 1,000. And since you wrote the script, every computer will interpret it the same way and do it the same way. And so not only can you achieve those efficiencies of scale that the baker saw when he made machines to make soufflés, but also you don't have the same scale of quality degradation that you would have with making soufflés. A task like resizing an image on a computer is a task that's natively performed on the computer itself, and every time you do it, it's performed in the same way and it outputs the same way. And that if you can use a Python script to just direct it to do that same task over and over again, there isn't any difference in quality. There isn't any loss that you get from trying to emulate a human performance, because humans don't do these actions any better, or frankly, in some cases, any differently than a computer would. A computer can just do it more efficiently or in the background without our interaction. And so where the baker lost efficiency because he tried to make a machine that would replicate his skill, and the machine did not perform at the same level as his skill, when we're talking about digital tasks like resizing images or sending emails, things of that nature, the tasks are performed at the same caliber by both humans and machines. And so when we write a Python script, it can often perform the same task in the same manner or in a more efficient manner than we could do on our own. That being said, like, these efficiencies and scale trade-offs are great, but at the heart of it, the core takeaway that I want you to get from this discussion is just that you can think of a Python script as just a recipe that we're handing off to the computer. We tell the computer, this is what I want to do. These are the ways that you do these things, and this is how you interact with the computer or with other programs in order to get these tasks done. And I want you to do them this many times, or I want you to do them in this particular way, or if there's a problem, maybe tell me about it. But these are all instructions that we can include in the recipes to tell a computer what to do. So with the souffle example, the baker was telling the machine to crack the eggs and whip them up to a foam and put it into an oven at a certain temperature, and left all these specific instructions for the machine. And in the same way, we would tell the machine, okay, open up the image and then, resize the image to 50% and save it, and then resize it to 75% and then save it, or whatever our specifications are. And we can tell it, just do that task over and over again, and we can achieve these efficiencies, and we can achieve these new scale of technologies. We can take a task that we might spend 4 hours doing for ourselves, and then when we write a script, not only do we save ourselves the time, but we can share that script with other people, and because other people's computers will run that script the same way, their computers will be able to achieve that efficiency as well. And so now you've not only saved yourself the 4 hours, but anybody else with 1,000 pictures that they want to resize in the same way, you can save them the 4 hours as well. And that's what programming is all about, is trying to find ways for computers to perform tasks or assist in the performance of tasks and make those things more efficient. And just as a side note, one question or one sort of pushback I get is, oh, well, you can't train a computer to do everything. You can't train a computer to think, things like that. And, with all sorts of really cool new technologies aside, computers will never be human beings. That's the fact of the matter. Computers and human beings are two separate things, and they will never be the same. One will never replace the other because they function in a different way. the way that, I don't want to get too philosophical with this because it's just a discussion about computers, but in broad stroke terms, a computer receives a set of instructions from either a human or another computer and performs those instructions in that way. And that's all that a computer does. That's all that a program does. That's all that's going on. Is the original programmer wrote a set of instructions, just like the master chef writes the recipe, and then then the programmer shares that script with other people, just like the master chef sharing that recipe with the other chefs. And so now anybody who has the Python script can resize the images, and anybody who has the recipe from the baker can make the souffle. It's the same concept. And so when we talk about, these efficiencies of scale, like, they do create new possibilities, but those possibilities are only things that happen if humans set their mind to do them. The computer didn't write the script to resize the images. The human who wanted to resize the images wrote the script with certain objectives, and the computer doesn't know why it's resizing images, doesn't even really have a full concept of what the data is. The computer doesn't understand what's going on. It just does the instructions. Just like how if you read that Master Chef souffle instructions, you might not really know all the proper techniques, but like, you're just doing what the Master Chef wrote, and chances are it's going to turn out okay because he's just writing good enough instructions, but like the user there is not able to really understand, just like the computer does not really understand, why or cannot write these scripts itself. And that's why, programmers are always necessary, because these computers, they don't do things that humans can't do. They just enable the amplification of the abilities of the humans who interact with them, So you want to solve a problem. Well, you can not only solve the problem for yourself, but now you can write a solution that you can share with other people, and they can solve their own problems. And so, like, technically the computer enabled you to help other people, but it wasn't the computer doing it. It was you taking the initiative to say, you know what, I have a problem that affects myself, and I would like to solve that for myself in a way that I can share the solution with anybody else, and they don't have to learn how to fix the problem. They just run the solution and it works. And that's what programming is. That's, in broad strokes, and that's what Python scripting is. And that's, with that lovely rambling introduction, I'm going to transition over to Trial and Error Assistant. Now, we talked in the Alexa video a little bit about Trial and Error Assistant, and this is the main script that goes over the core functionality of how Trial and Error Assistant works. If you didn't watch the Alexa video, I recommend you check it out. At the end, I talk a little bit about Trial and Error Assistant, but basically the structure is that Assistant is a voice-activated interface that you can use to interact with your computer in the same ways that firmware on Amazon Alexa devices or Google Home devices operate, but without having to invest in a separate piece of hardware, because you already own the computer, and you can teach your computer how to do what a Google Home does, rather than buying a whole new device to get this new functionality. And so I'm going to just kind of walk briefly through here just what this code is talking about. Just for anybody who's not familiar with Python code, all these are imports, so we don't need to worry about those, and we're not going to talk about this new stuff down here. We're just going to talk about this section here, right where it says from define run assistant and on. So I'm going to minimize these. These are comments that I'm hiding. They don't matter for the code. They're just explanations, but I'm going to be your explanation, so you don't need them. If you'd like to check out the source code, I'll put the link in the description below to the GitHub page. But yeah, so the general concept is, in a Python script, we start from the top and we go straight to the bottom. So line number 1, there's all these imports. I'm just showing and hiding lines, but if you look at the line numbers on the left-hand side, you'll see line 1, line 2, line 3. We're just going line by line. Think of this like a Word document. Python scripts are just like Word documents, but the words aren't in English, they're in Python. And so they have special grammar and rules and stuff, and you'll see there's certain colors and stuff. Those all correspond to grammatical rules in Python. And we won't exactly describe everything here because it's just a 100 days episode, but all of these statements are bringing in all of the different pieces of code that I've set up, which are all located in different files, but this is the file we're going to talk about today. And this def keyword is what's called a function definition. It's just saying that we are creating a function. So what's a function? Well, let's bring it back to the souffle example. Let's not talk too much about Python. Let's talk about baking a little bit here. So if you're going to make a souffle, I think that one of the steps, I probably should have researched how to make a souffle before I start talking about souffles. So let's talk about making peanut butter cookies, because I love making peanut butter cookies. So one of the steps is, like the steps involved in making peanut butter cookies is, add the butter, add the peanut butter, add the blah, blah, blah. And so here, this is like telling me, okay, how do I run the assistant? Here's all the steps. So a function is one thing that a program does. And I'm breaking the rules a little bit here. So, but for the sake of explanation, running assistant is just running the whole assistant from start to bottom. How does an assistant work? An assistant starts off by listening, and they listen to what you say, and then they analyze what you said, see if there's a wake word. If there's a wake word in it, then they will wake up and they'll listen to what else you said, and they'll interpret that as a command, and they'll go do it. So if I say, hey Alexa, get me the weather, then Alexa hears, hey Alexa, and knows that's the wake word. So she wakes up and she hears, get me the weather. And so she goes and gets the weather, and she comes back and says, hey, it's 72 and sunny, you live in California. I don't live in California, but that's something that she might have said when I did live in California. So 72 degrees and sunny, and so that's how she works. And so if all we need is something where I can tell it a command like get me the weather, and then have it give me back the weather, well, that sounds awfully like something I can do on my computer. I don't need a separate device for that. So I'm going to tell my computer, hey computer, when I say with my voice, get me the weather, I want you to get me the weather, I'm going to use a different example here. I'm going to say, I want to know who Napoleon is. I like this one. Search for Napoleon, I want to know who Napoleon is. And so I tell my computer, hey assistant, search for Napoleon. And it will search Google and figure out who Napoleon was and tell me that back. It's the same functionality. It's a similar way of operating, but here, instead of buying a device that will do that for me, I'm just going to write the instructions in ways that my computer will understand. So how do we write those instructions? Well, what we do is we give the computer a series of functions. Remember that a function is one thing that a program does. Give it a series of functions and chain those functions together so that it has a roadmap on how to proceed. Sort of like a choose your adventure book. So you tell it, hey, at this point you're going to need to make a decision. If something's happening, do this, otherwise do that. You're making a souffle. It says whip the eggs. If the eggs get frothy, great. If they start sagging, stop whipping, because you're whipping too much. So right there, it's like a choice. You come up to, like a dilemma where you've got froth and eggs, and you're trying to determine when you should stop. And there's instructions on, if it's this, you should stop. If it's this, you should keep whipping, so on and so forth. And so here, the program has multiple functions, and you chain these functions together with instructions on when you should do them. Like, when should you whip? You shouldn't just put the sugar in the bowl and then whip it. You only whip when you've got something like eggs or butter or something like that, or maybe you want to keep all the dry ingredients in one bowl and the wet ingredients in another. And those are all different things that you could define using functions for your script. So without belaboring the analogy too much longer, I'm going to go through here, and you see on the side, the line numbers are going up. So we start at the top and we go down. This is the beginning of the function. Everything that you see how there's a tab right here? All this stuff that's indented, this is all within this function. All of this code is within this function, so on and so forth. So the run assistant function is just all of this code because you see the indent. Once the indent ends, the code, it's no longer the function, it's a new function. So this is how we define the run assistant function. I named it run assistant because I want to make sure that I remember what it does. So if you saw the video, this will be a review, but the way that this works is you start off with this line, and it's a little bit tricky the way that you read Python. Sometimes you read it right to left, because of the assignment equals here. So I'm going to go really simply, and I'm going to say it starts off by listening for commands, and when it hears a command, it returns a command, str, or returns the command as a string. We're going to turn that into a lowercase string, return a copy of the string converted to lowercase, as our command. So, one more time, it listens for commands using the microphone. This is another function somewhere else that handles the microphone and listening for the commands. We're going to go back here, just listens for the commands. When it hears a command, it returns it, and so it as a lowercase string to commands. So when I tell it a command using my voice, it converts what I said into text and saves that text in this command variable. So in terms of our instructions for our assistant, what we want the assistant to do, our first line here, line 25, all we're telling it is when you hear a command, figure out what I said and write it down as text, because I want you to know what this command is in a text format. Why? Because computers don't naturally have ears. They don't really know how to understand audio naturally. You can train a computer to interpret audio signals and match it against previous things, but we don't want to teach the computer how to listen. We just want to use a Google conversion API that they have speech to text. We just want to use their API to convert whatever I said into a text command, because I honestly don't care if it knows what I'm saying. Google will figure out what it's saying and send me back the command as a string of text. So based on this first line, we've gotten, I've set a command like search Napoleon on Google, and it has figured out, okay, I heard what it said, and Google's telling me that this string of text should be search Napoleon on Google. So I'm going to keep going down. More comments, don't worry about those. Next line, we're going to check whether there was a wake word in our command. We're passing in our command, and our command is the entire string of text that we said. So if we say, hey Alexa, get me the weather, the whole command would be, hey Alexa, get me the weather. And this check for wake word function, the thing that it does is it checks if the wake word was in there. In our instance with Alexa, the wake word is Alexa. So when I say, hey Alexa, here's Alexa, and it says, oh yep, the wake word is there. So I know I need to wake up and I need to listen to what else was said and do that thing. There's a little bit of fire trucks there. So it checks for the wake word. If it hears it, the wake word Alexa, if it hears Alexa in the sentence, then wake word detected will be recorded as true. It says bool here. That's a Boolean value. What's a Boolean value? It's true or false. It's only two states, true or false. Those are the two things. So it's either true that the wake word was in the sentence, or it's false, the wake word was not in the sentence. So that wake word detected will be able to store whether or not the wake word detected was in there. Well, let's take a step back. Why is that important? Well, I want the digital assistant to know if the wake word was in there, because if the wake word's not there, it shouldn't be listening to me, right? Alexa should not be listening when I don't say her name. For this script that I've written, I've actually coded it so it doesn't care. It will still do it even if the wake word isn't detected, because to me, I don't care whether or not there's a wake word used, because at the end of the day, this digital assistant only runs when I run it. So it's not always listening to me like we talked about in the Alexa video. Instead, it only will start listening once I press the button to say, hey, run this program. So I don't have to worry about an always-on microphone. So because I don't have to worry about wake words, then I actually don't need any of this, but I included it because I wanted it to function just like a digital assistant. So getting back to here, we've got our command, which was a string of text. We checked whether there was a wake word, and if it's detected, then wake word detected is true, and if it was not detected, wake word detected will be false. And here's where we have a decision point. We have to teach the digital assistant how to make this decision for us. So we have if wake word detected. So this is our next line of code that's going to be executed, if wake word detected. What does that mean? Well, if is just like it sounds like, if. So if wake word detected. Now, it's a little bit of a grammatical mystery. This is a Pythonic way of writing things. It's not super clear. I can include if wake word detected is equal to true. And what that means is wake word detected true? If it is true, do this stuff. Else, which means if it otherwise, or if it's not true, then do this stuff. And that's how your basic if statement works in Python. It's just a choice, and you say, well, is wake word detected true? Then you should do this stuff. Otherwise, if it's not true, then do this stuff. Just like, are your eggs still foamy? Then keep beating. Are they starting to sag? Stop beating. It's the same sort of logic. Do one thing or do another thing depending on the state of your eggs. And here, we're doing one thing or another thing depending on the state of this variable, wake word detected. And it's, very simple to understand that, or very simply explained here, wake word detected. If it's true, do this stuff. If the wake word is detected, we do this. Otherwise, we do this. And let's walk through it. What happens if we have the wake word detected? Well, let's talk about it before we talk about code. I'll cover up the code like this. What do we expect to happen when the wake word is detected? Coding aside, think about it from a project point of view. We expect that if the wake word is detected, then you're gonna listen to the rest of the command and you're gonna do that command, right? 2 steps. Just figure out what the rest of the command said and then do that command. Maybe you gotta tell me something back, but that'll be part of doing the command. So there's only 2 steps here, right? So 2 lines of code. First step, cut the wake word from the command to get the command without the wake word. Keep in mind, hey Alexa, get me the weather. We don't need the hey Alexa part. We don't want Alexa to worry about that anymore because that's all dealt with. Instead, we just want the last part, get me the weather. And so we have cut wake word from command. So we cut out, we take where I said Alexa and we take that word and everything before it and we toss it. We get rid of it. We don't need it anymore. We just take the second half, which is it's get me the weather. And so command without wake word will be get me the weather. Then what do we want to do? So we have get me the weather, well, perform the action, get me the weather. And so I have this function here, perform action, get me the weather. Now this looks really simple, right? Perform action, easy, done. Well, here's the thing though, right? Perform action is another function that I've written. So let's go look at perform action. It's down here. Got a little bit of code. If the action is play, if the action is wiki, what it does is it cuts the first word out of the command string, and then it says, is the first word play, is the first word wiki, is the first word search, is the first word open, and it uses certain parameters to figure it out. So it's a little bit more complex behind the scenes. This is all code that I've written, but in general, all it's doing is perform the action, which is the command without the wake word. What's the command without the wake word? Get me the weather. So you perform the get me the weather command and does that. So let's talk about, we just talked about what to do if the wake word is detected. Just get the command and then do it. What about if you don't hear it? What if I just say get me the weather and I don't say hey Alexa? Well, let's go back and talk about how this program only runs when you run it. So I don't really need it to listen in for a wake word. I just want it to just do it anyways because I ran the script for a reason and I want it to get me that information. So if wake word is detected, then we're doing all this stuff. Else, meaning if the wake word's not detected, then let's check if the settings, looking in the settings, do we require the wake word? If assistant settings.get require wake word equals false. Well, what's this? Assistant settings is just a dictionary with some settings, and you see require wake word is false. So by default, it doesn't require wake word. We can change this to true if we do want it to require the wake word, but I'm not going to do that. We're going to come back here. We're going to just check, do we require the wake word? Since it's going to be false, it's going to be false. And when we say if assistants get require wake word, that means that if the value that we get when we check the settings for a require wake word, if the value we get is true, do this thing. Otherwise, do this thing. See? If it's true, we're going to do this. Otherwise, we're going to do this. So if when we check whether a wake word is required, if that's true, then we need to just send an error. This is just send an error. The wake word is required. I didn't hear the wake word, so I'm not going to do anything. And that's what you would expect. If you are expecting it to require a wake word, then when you don't say the wake word, you shouldn't get it activating. Otherwise, which means if when you check if the wake word is required and you get false, then you're going to say in the log, the wake word wasn't required, so I'm performing the action, and then just go ahead and perform the action anyway. So you see perform action, it's still going to do it. And so that's the general basic structure of how run assistant works. And as you can see, that this core structure of the program is just like that souffle recipe. We're walking them through. We say first listen for a command, get the command, turn it into a string, and then check to see if the wake word was in there. If the wake word's there, then you should do the stuff. Otherwise, if the wake word's not there, then you should check if it's required. And if it is required, just give me an error. If it's not required, do the action. That's the entire structure of trial and error assistant. Every other piece of code is a sub piece that helps handle all these things. And if you look at the actual files, you can see that there is a lot of Python files and different things in here that all contribute to this core functionality. But this is like the overall process map, like the overall recipe of how to make a souffle. And then all these different files in here are like how to mix flour, how to whip eggs, how to add sugar, how to preheat an oven, what is an oven, all that sort of stuff would be included in these subfiles, but the main function is here. And so just to kind of bring it all the way back to where we were talking about earlier with Python scripts as recipes and trial and error assistant, is that if you can understand what it is that you want your program to do, if you have a problem and you're able to solve that problem, or at least make things more efficient by using a Python-based solution, you're not only solving the problem for yourself, you're solving it for other people, and you're able to amplify that solution so much greater. Like, let's say that the problem you're trying to solve is that your windows on your computer keep accidentally minimizing, and it turns out that there's a Python script you can run to prevent them from accidentally minimizing. If you can solve that problem for yourself, that's great, whatever, you save yourself a little bit of time. But if you can solve that problem for every other person that has that same computer that you have, well, now you're talking about really helping a large group of people through working through your problems and finding these solutions. And so I highly encourage everybody to do their best to try and at least understand these basic fundamentals of why people write Python scripts, what a programmer does, and what programs are, so that you can at least understand when is a good time to take a problem I have to a computer and see if there's a solution. Because, like the idea of, oh, I want to know information and it's too cumbersome to go to the library is something that a lot of people probably felt 50 years ago, and now we have computers that solve that problem. You can just go online and look the information up. But now, if being near a computer, or you have limited mobility, or you want a more convenient way of interacting with this information, well, that's what digital assistants came out of, and they're super great and super handy. But the concept that you have to pay money for new pieces of hardware to achieve a task that your own computer could do easily just in its spare time, it sort of begs the question, why would you want to invest in one of these assistants if everything that you want is something that your computer can do, as long as you learn how to teach it how to do it? And so, just like that master chef who wanted to make a souffle for everybody and share his wonderful creations with everybody, I want you guys to be the sorts of people who have ideas on how to solve problems and can either work on figuring out solutions that you can use Python for, or just technology in general for, to amplify these solutions and share them with more people, or just learning why programming is important and when to bring in a software developer and say, hey, I've got a problem and I've got a solution, and I want to know if you can build this solution out for other people, and maybe we can make some money so that we can keep finding more solutions to similar problems and keep the ball rolling. And I can spend my time finding the solutions, you spend your time writing the programs, and then we share this solution with everybody, and everybody can just run it, and it works exactly the same way. And I think that at the end of the day, that's just the beauty of programming is it's about a bunch of humans working together and magnifying their voices to solve problems and to find new problems to solve, honestly. You solve the problem of convenience of information. Now we have to solve, making the voice sound better, or better, voice training algorithms, or, digital assistants that, can follow you around or something like that. So the opportunities are all out there. And I think that, if you're watching this video, maybe you've got a solution to a problem, or maybe you have a problem you want to solve and you're interested in learning about Python or just learning about technology in order to solve it. I encourage you to, just keep trying new things, because the more new things we try and the more opportunities we have and the more perspectives we have on every problem, the better prepared we will be to solve the problems that face us. And with that, I want to thank you for watching, and I hope you enjoyed, and feel free to leave a like if you enjoyed the content, or leave a comment if you have any questions or suggestions on further videos to come. And with that, thank you very much.